SQS Amazon SQS, or Simple Queue Service, is a fully managed message queuing service offered by AWS. At its core, SQS is designed to decouple and scale microservices, distributed systems, and serverless applications. It allows systems to communicate with each other by sending messages through a queue, without requiring direct connections or real-time communication. Imagine a situation where you have a web application that processes user image uploads, rather than having your app handle the image processing directly, which could be slow and resource-intensive. You can send a message to an SQS queue with the details of the image. Another service, running in the background, listens to that queue and processes the image when it's ready. This kind of asynchronous communication keeps your app responsive and scalable. SQS offers two types of queues, standard and FIFO. Standard queues offer maximum throughput, best effort ordering, and at least once delivery. They're perfect for most applications where it's okay if messages are occasionally processed out of order. On the other hand, FIFO queues guarantee that messages are processed exactly once and in the exact order they are sent. These are ideal for use cases like financial transactions, where order and precision are critical. One of the biggest benefits of using SQS is durability. Messages are stored across multiple availability zones within a region, ensuring that your data is safe and available even if there's a failure in one part of AWS's infrastructure. SQS is also highly scalable. It can handle a massive volume of messages without needing you to manage any infrastructure. You don't need to worry about servers, patches, or scaling. AWS does it all for you. Messages in SQS can have a retention period of up to 14 days. This gives your systems plenty of time to process them, even during heavy loads or downtime. You can also delay message delivery, making SQS useful for scheduling tasks to run in the future. To integrate SQS with other AWS services, you can connect it with Lambda functions, EC2 instances, S3, and more. For example, a new file in S3 could trigger a Lambda function, which sends a message to SQS, triggering a processing pipeline. You also have control over message visibility timeouts, dead letter queues for handling failed messages, and access control policies to secure who can send and receive messages. To sum it up, Amazon SQS is a powerful tool for building resilient, decoupled, and scalable applications. Whether you're handling millions of messages or just a few critical tasks, SQS provides the flexibility and reliability you need to keep your systems running smoothly. Let's explore the limitations of AWS SQS and compare it with Google Cloud Pub/Sub and Azure Service Bus in terms of capabilities, performance, and use cases. Limitations of AWS SQS. 1. Message size limit. Max message size is 256 kilobytes. For larger payloads, you must store the data in S3 and send a pointer. 2. No native push mechanism. For standard queues, SQS is a pull-based system. It doesn't natively push messages to consumers like Pub/Sub does, unless you manually wire it with Lambda or SNS3. Limited message ordering. Standard queue. Standard queues do not guarantee message order. You need FIFO queues if you want ordering, but they come with reduced throughput POT4. Limited FIFO throughput. FIFO queues support 300 messages per second, or 3000 with batching, which can be a bottleneck in high-throughput systems POT5. No built-in filtering. Unlike Google Pub/Sub or Azure Service Bus, SQS doesn't support message filtering by attributes directly. You'd need to handle that in the consumer logic. 6. No dead letter queue, DLQ, for FIFO queues until recently. DLQ support for FIFO queues was introduced later and still has limited use cases compared to other platforms. Dead letter queue, DLQ, support for FIFO queues. AWS SQS now supports dead letter queues for FIFO queues, but this is a relatively recent feature, introduced in late 2021. What is a DLQ? A dead letter queue is used to capture messages that can't be processed successfully after a certain number of delivery attempts. Instead of losing or endlessly retrying a message, SQS moves it to a DLQ for later analysis or debugging. How it works with FIFO. You can set a maximum receives threshold, for example, 5. If a message is unsuccessfully processed 5 times, it is automatically moved to the DLQ. The DLQ itself must also be a FIFO queue if you're using it for a FIFO source queue. So yes, DLQs are supported for FIFO queues, but they must also follow FIFO constraints, meaning the DLQ must be FIFO too, with the same message group ID patterns if needed. What does it mean that SQS does not support push? When we say SQS doesn't support push, we mean that SQS does not automatically deliver messages to consumers. Instead, consumers must pull the queue to check for new messages. Pull-based model, SQS. Your application, or AWS Lambda, pulls SQS. You call receive message to fetch a message. If there's a message available, it's returned. Otherwise, it waits up to the long poll timeout, or returns empty. Push-based model, for example, SNS, pub/sub. In a push model, messages are automatically delivered to subscribers, for example, via HTTP, HTTPS, Lambda, or email. You don't have to poll or ask for messages, they're pushed to you as soon as they're available. Workaround. You can simulate a push behavior in SQS by integrating it with AWS Lambda, which will pull the queue on your behalf and trigger your function when a new message arrives. But SQS itself is not natively a push-based system. It's pull by design.